12:48. Good afternoon. It may be that you watch this video in the evening. Good evening. If you're gonna watch this in the morning, good morning. My name is Kunda, as the profile indicates. Today, I want to discuss with you a very, very important topic, which has just been added to the Zambian curriculum, both at grade 9 as well as grade 12. I think across board, even grade 7, they are doing this. So we'll be looking at computers. I may not, my camera is a little bit twisted because of the position. Okay, so it's, okay, that's okay. I may not go in detail now. You need to bear with me that there is ICT, which is introduced in schools. And then this computer I'm talking about is just a mathematical component that is present at both the grade 9 as well as grade 12. I'm not too sure about grade 7. And so if you have done ICT from a broader picture, you will find that there are some differences and similarities that will exist between the two. And the reason is this ICT, I'm not going to focus much on the programming point of view. I'll just be on the surface to do with the mathematics. And I may not do much of a theory. I'll focus on the questions. All right, so what is a computer? Computer, in the simple and easy explanation or definition, I'm going to call it an electronic device. Electronic device that is able to perform the following processes. The following processes. The electronic device that is able to perform the following processes. Process number 1, it is able to process data and make it to be information. That's the first process that it does, is to process, as the name suggests. And the other one is that this computer should have the ability to accept the information or info or data. Now, when it accepts, you should have, when someone gives you money and you accept, you should have a point where you are going to keep that money. So you should have a storage facility. It can never be a computer when it accepts the information and then it doesn't have anywhere to store it. The other point that it should be able to do is that it should be able to display our output, the information. What do I mean is that the computer should have a component somewhere which is able to show what you are doing. Let's say you want to play a song, you want to play a video. I don't know your favorite song, but my favorite song is gospel. You want to play a gospel song. So what's going to happen is that, especially if it's a video, there must be something which will be able to display the picture. Not on that, there must be something that will be able to produce the sound output. And then the fourth one, there are many more, but I'll just bring out the basics. There must be a part somewhere that is able to allow the input of the information. Yeah, so there must be some component that is able to get the data or information from an external world and brings it inside the computer. Let's want to download. You want to type something, there must be an external part, let's say a keyboard, that is transferring the information inside of the computer, which I will come look at these components later. So if you have an electronic device that is able to perform this and many more, then you'll be rest assured to say that that is a computer. So away from that, we are now going to look at examples of computers, examples of electronic devices that is able to do that. That is able to do that. So the electronic devices that are able to perform the earlier itemized processes as follows. Examples of computers. One, you can have a desktop. You can have an iPad. You can have a tablet. You can have a PC, personal computer. There are many more, but basically these are the ones that are common. I think even a smartphone can be included here. But now these are the ones that we're going to look at as example of computers. Now, there are words that are associated with computers. There are certain terminologies that are very, very, very much important associated with computers. Ways such as what is data, what is information, what is a flow chart. Those things, we may not talk about them. I'll leave them with the programmers. But for now, I'm interested in looking at the components of a computer. Components of a computer, or features, I would say. Features, no. Let's just say components. We just say components. Okay, so if I say components, which ones am I focusing on? I'm focusing on the following. You see, those processes that I brought earlier, those processes may also come here as part of the do I say components? Oh, let me say processes, just and the same. So now a computer needs to have this processor. So the central point of it, just like a human being is able to carry out a lot of processes. A human being is able to think, a human being is able to store the information, a human being is able to reproduce. There are quite a lot of systems that are there. So with the computers, but with a human being, all those processes are connected and controlled by the brain. So even here, the central point of this computer is a processor, but we call, so we're going to say processor, which we'll call CPU, Central Processing Unit. And then after that, this CPU is able to take the information out of itself, taking it outside, which we can call output as one of the processes that we looked at. Now, the devices that are able to output, we call them output devices. Output devices, the examples that we can look at, we are looking at items that are able to get the information and then taking it outside. You can have a speaker. You can get a speaker connected to the laptop or the computer and find that when the song is played, you get the song or the sound outside the computer. So you can go for a speaker for now. The other one that you can look at is the printer. A printer cannot print anything of its own. The command comes from the computer. You can never get any information from the computer, from the printer. It comes inside, unless you go for a scanner or a multi-task devices. So here you can go for a printer. A printer can only get the information. The printer cannot print anything unless it comes from a computer. Then the other one that we can look at, is the is a monitor. See, a monitor cannot display anything of its own. This is screen of a phone cannot just get a screen and have it walking on the road that I'm seeing something. You can never do that. The monitor displays, outputs the information from the computer. And you can never get anything from the monitor, you put it inside. The other one which you can look at is that which brings the information inside, input. That device, we're going to call it input device. Now, this time around, we're talking about these components that are devices that are able to get information from the outside world and brings it inside the CPU. The good example of it is this thing I have with me right here. Oh, where are you guys now? Here, you can never find a computer, you can never find this thing connected to a computer. You can never transfer a song from a computer. It comes in and be stored in the keyboard. It's not possible because this thing can only take the information input devices. When you're typing, you want to change the password, when you're typing, that information goes on the CPU and then the CPU takes it to the monitor to display. Okay, so the good example here is a keyboard. The other one is the mic. We see when you have a mic connected, not the headsets. Headsets have both the mic and the speaker. Just talking about ordinary mic. Okay, when you're recording a song, the song goes into a CPU, then the CPU goes to the component that we have to look at. So the microphone. They're quite a lot. The other one is a scanner. You see, that's why I disqualified the headsets. Headsets have both the speaker as well as the mic. So if you're talking about now a multi-purpose device which does scanning and printing, not talking about that. Just talking about the scanner just meant for that job. Now, you see, if you want to scan a document, you get a document which is outside the computer. Outside. You get a document, you put it on the screen of the scanner, you do the commanding from the processor, from the computer, and then the scanner will get now that image, capture it, take it inside. If you want to store it in form of a PDF, in form of just an ordinary picture, it's entirely up to you. But the bottom line is that the information comes from the outside, goes into the CPU. And then we have this thing here, which does the two, getting in and taking out, storage device. The storage device is able to get information from here, goes here, and then it is able to take back. Speak of downloading a song. When you download a song, you're getting from an outside environment. So CPU is stored. Now, when you want to play that song, you get it from you can be the flash, okay, which you connected to the computer. Then you can remove the flash, you go with it to the market. You want to play the song you downloaded and stored in the computer, you connect it back, you get to have the information going back, and then the speaker gives you the good sound. So, remember what I said about the brain. The brain coordinates every process that the body is able to undergo. So the CPU is a central point of it. It's able to coordinate all these processes. So calling it central processing unit, central processing unit. So it's able to coordinate. You can never get to have the keyboard. You type a word, it does not come here. It just goes direct to the monitor. Run for your life. Something is wrong. Something wrong with this. Fix it. Don't happen. You get to have a song. You get to have a keyboard. Types a letter. You type a letter. It goes here and then comes here. This is able to regulate how much information can go here. You've seen a situation. You have a 2 GB flash drive. Then you want to put a movie, a very big movie. It's able to regulate. To say, no, that movie is way too big. It can never store in that flash. It's able to regulate. Phones, if you download a very big file, a picture, very big file, you put it as a screensaver, only the screen of a small phone, it will refuse to say the picture is way too big, the CPU. Okay? And that is the introduction that I can give. Now, away from that, at grade 9, this video is multi-purposely made. Like what I've done so far can be for grade 12 as well as for grade 9. But this basically for grade 9, because they like asking which one's an input device, which one is output device, which one is the storage facility. Oh, I have not given examples, but I think I just did one. So we can speak of the flash, you can speak of the hard drive, you can speak of the disk, you can speak of the micro SD. Those to my memory cards. Those are examples of storage facilities, storage devices. So let's go to the last part of the discussion. I'm not going to look at it from a wider range of it. No, for now, because I have a class to attend to at classes actually. One just got it done. I have another one at 14, then the other one at 16, and then I'll be tagged for the take. So let's look at the last part of today's presentation, which will be the combination of the pseudocode and the flowchart. So we will look at the pseudocode. I'm not too sure about the spelling, as well as the flowchart. Now you see, a pseudocode, maybe by definition, from my way of defining it, I would say it's a step-by-step procedure that examiners use when executing duties. A step-by-step procedure. Let me just write some few things. Step-by-step procedure. Now you see, if there's a procedure, when the procedure is given and it has to go stepwise, you can never skip a step. You can never skip a step. The good example away from this thing we're talking about, cooking in shima. How do you cook in shima? Do you get mini, you put in water and start stirring, and then on you put on the fire? You're not following the procedure. The procedure has to be get the water, put on the fire. When the water becomes a little bit warm, add a bit of sugar, add a bit of mealie meal, make that paste, let it boil so that the solid part of the mealie meal you put in water can and then thereafter you add the more of the mealie meal. The cooking continues. You see, you can never eat hishima which you did not prepare. You can never cook hishima before buying a mealie meal. So you see, there is a procedure that we follow step by step. You can never apply lotion before bathing. You can never bath before preparing the water. So there are quite a lot of procedures that we follow in life. Procedures are what guides us in life. So pseudocode, at times they'll give you just a procedure, just procedures like that. Then they ask you to bring out that procedure to present it in form of a flow chart. Or times they'll give you a flow chart, then you take it to the pseudocode. Okay, so a flow chart, I would say, is a chart which indicates step by step procedures that you need to carry out. Now, be reminded that we're just saying procedures are a lot. It could be that maybe they want you to give the procedure on how to find the density on a given mass and volume. It could be that they want you to give the procedure of how to find the velocity when the mass and the distance and time is given. It could be that they want you to give the procedure of how to find the volume of a cylinder when the radius and the height are given. So it's just a procedure. So it's just coming from a wider and a broader arrangement. So for now, I may not even talk a bit of pseudocodes. I want to introduce the flowchart. I want to introduce the flowchart so that we understand it better when we say a flowchart and what is it that is involved. Mostly at grade 9 and grade 12 labels, they like bringing a pseudocode. They ask a student to take it to a flowchart, but they may give you a flowchart and then they ask students to convert that information and put it in form of a pseudocode. So for now, the last thing is the flowchart. So this flowchart you see, it's just a chart. Flow, it's giving us how steps, how things are supposed to move. Flow, the flow of water shows where water is coming from and where the water is going. It's a chart, diagram of some sort. So now, what is it? And what does it involve? When I told you to prepare a chart in class, you can have a diagram, you can have arrows, you can have shapes, you can even draw this shoe, you can even draw anything can be contained in form of a chart. But this chart what we're talking about supposed to have ways of flowing from one step to the other as we execute the duties. This chart in flowchart, we rely much on shapes, plane figures. So those are the ones that I'm going to be using. I give you the shape or the plane figure and what they represent in the flowchart. Now you can never, like I said, these procedures, you can never make a phone call. You can never call your dad. You can never call your mom minus turning this thing on. So the first thing is turn on the phone. You start. So the first thing on the flowchart, you need to start. Now, you see, certain phones, even a computer, which is an example of a computer, a desktop for that matter, the same button that you use for starting, the same button that can be used for stopping the program. You want to turn on, you use the button. You want to switch it off, in that way you can use the same button. So for a start and a stop, we use the same shape. So stop, we use the same. Now, you see, when you turn on the PC, you want to use the procedure. When you turn on the PC, what do? If it has a password, you enter the password. Input. You're entering the password using a keyboard, which is an example of an input device. So you need to input. Input or enter, they are the same. Now, you see, this, or maybe let me not do this. This This thing you see here, I just thought I gave out my iPad to someone. I could have used it as a teaching aid. Now, this phone that is in, if it has a password, the same screen where you're entering your password as an input is the same screen that we're going to use even to see what is written on this phone. So, like someone sent me a text, yes, brother, I didn't know who this guy is. So, because the same screen that we're using for inputting, also the same that we're using for seeing, displaying what is coming out of the computer, we use the same shape for output as well as display. So in the flow, in the pseudocode, when they mention the word enter, input, display, output, this is the shape that we must focus on. So this was one, this was two. The third one is there are times you want now the computer to carry out an action. You want the computer to play the song from the output. You want the computer to solve the question for you. You see, computers have got Excel, and Excel can be used to calculate. You want to calculate the volume, like I said, when I'm giving the procedure, it could be the procedure is that they want you to find the volume when the mass and the density are given. So when you're carrying out an action, I'm going to emphasize on this. We use the formula in pseudocodes. When you just see the formula, when you just find the formula, just know that we're talking about an action. And that is just that. Now you need to put a clear-cut distinct between the input-output shape as well as the action where we use the formula. This is a twisted rectangle, like someone held from here and then held from here, then they pulled it to form a parallelogram. That's the thing that we have here. And this one is a perfect rectangle, represents the action. But again, there are moments in life when you turn on the PC. When you turn the PC, it will load. When it is loading, it is connecting to the BIOS battery to detect the operating system that is in the computer, and then it will ask for a password to enter. When you enter the password, you see it loading again. When it is loading, what is it doing? It is making a choice. It is making a choice. Whether the password you entered was correct or whether the password you entered was incorrect. So at that moment, the computer is now deciding. So there is a decision shape that we use. And the decision shape looks like that. And here they like asking a question to say, if, let's say, if the height is less than 0, now when they say if the height is less than 0, when you're writing in here, you need to ask yourself, is the height less than 0? There are only two answers there. Either the answer is yes, it is, or no, it's not. When you are making a choice, deciding for something, some of us want to make a choice. Right now, I've not eaten, I want to decide. Am I supposed to eat because 14 approaching? I'm about to eat later. I'm making a decision, so I'm making a choice. There are two things that I'm likely to do: either yes, I go on, or no, I don't. Now, you see, again, even when you are making a choice here, deciding, let's say you enter the password. You enter the password, and then you discover that the password is wrong, incorrect. The PC will never go off. It will ask you to re-enter the password. You see, you turned it on the PC, you entered the password. Okay, you turned on the PC, you enter the password. Let's forget about this. And then you enter the password. It is loading. When the password is wrong, it will ask you. When wrong, it will ask you to go back and enter the password. And if it is correct, it will now ask you to perform an action. So the way the pseudocode comes, will depend on the way you are likely to present the flowchart. Depends on how the pseudocode comes. The way the pseudocode comes will guide you on how the flowchart comes. There are times you can just start here. I've seen questions, especially grade 9, because there the content is a little bit low. You can just start, you enter here, formula, again, display the answer, you stop. You see? You, like, example is a calculator. You turn on the calculator, you enter the figures. On the calculator, you don't write the formula. You just divide. 14 divided by 2. And then the formula, the computer itself will do it. Then thereafter, it's going to display the answer. After displaying the answer, you turn off without even making a choice. But at grade 12, because there's a component we call looping, where you are able to enter into the area indicated item. So for now, that's where I just end. But I'll urge you, when they ask whenever you see the formula, you need to write it in this shape. And then the other important thing is when there's looping from here, they ask you to go back either here, but mostly they go back to the importing shape. At times they will say, when you enter the password is incorrect. It will tell you that that you have entered an incorrect password. That is the information which will be displayed on the monitor. Okay, so in an event where you are told to go back to re-enter the password, there must be some message which will be displayed on the computer. Or maybe it will tell you invalid message or invalid answer. That message which must be displayed before you enter in here will always be given. Let me just give you an example of let me go to this. Look at this question here. Display an error message. So they'll say display, what are you displaying? Error message. So the error message is put in inverted commas to indicate that that is what will be displayed. So you write here, display error message, or if not, you can just write error message because this is a display shape. You see? So the next video I'm gonna make, I will be talking about how to handle such questions. Okay, I think that's where I'll end for now. If you have inquiries, you have questions, you have clarifications, learning is a two-way thing. As I'm talking like this now, there's quite that I'm learning. Okay, you can never teach the same topic 3 classes using the same ways. It's not possible. The way I have presented this today, or let me say now, is different from the way I was presenting a few minutes ago because I was having a class. It's different. So for clarification, contribution on how I can improve my presentation, you can just reach me on this phone number +26 097557869 or my email is coolndr59@gmail.com. I'll definitely respond to that.